In this problem, we have an improper integral, right? We're going from finite to infinite of an exponential growth function. Now, you know what these look like, right? Exponential growth functions look like this. Now, if we go from 6 all the way out to infinity, think of it as area out here, what do you think happens as we keep going this way? I think we keep adding so much area that this thing is going to diverge. I don't think this is going to come to some particular number. Let's prove that. So we'll rewrite this in our form as the limit as b goes to infinity of the integral 6 to b of e to the 5x dx. This will be the limit as b goes to infinity of, now let's actually do this. We'll get e to the 5x over 5 from 6 to b. Put in the upper limit. Limit as b goes to infinity of, okay, e to the 5b over 5 minus, put in the lower limit, e to the 5 times 6 over 5. Now, what happens in this first case? Look what's happening here. B is getting bigger. So 5 times b is even bigger. And then e raised to a bigger and bigger power keeps getting bigger and bigger. The denominator is fixed at 5. So you know what happens in a fraction. When the numerator gets bigger and bigger and the denominator stays fixed, this whole thing goes off to infinity. Now, it doesn't really matter anymore what this does. That's just, right, e to the 30th divided by 5. It's just some number. We don't know what it is, just some number. But this thing is getting bigger and bigger, and you keep subtracting some number. The whole thing is still getting bigger and bigger. So this whole thing is going toward infinity. We're going to say does not exist. We're going to make this conclusion then that the integral as x goes from 0 to infinity does not exist. That means, in terms of area, this area just keeps getting bigger and bigger and bigger, is not approaching any finite value.